Okay, so what we're looking at then is trying to work out the coefficients of x squared and x, and also the constant there, c. So in order to do this, we look at the minimum value there, 5 minus 3, and also the x-intercept of 4, 0, and we're going to use these values to help us work out those missing coefficients. So there are different ways that we can do this. We're going to start with one method which utilises the minimum point first and our knowledge of completing the square. So if we use 5 minus 3 and then write out the quadratic in completed square form, so we know the 5 is going to relate to x minus 5 in brackets squared, and the minus 3 will simply be minus 3, the y component of the minimum point. So now we've written this out, we can then expand this out totally, and we know that if we expand that out, that our coefficient of x squared is going to be ax squared, so this is what we're looking at. And we'll then be able to substitute in the other values we know, because we know that 4, 0 lies on the function that we're looking at. So we'll be able to substitute that in and then work out the value of a. So first of all, I'm just expanding it out, which takes a while, sorry. So if we expand all of that out, we can now substitute in x equals 4 and y equals 0. And if we do that, hopefully we should be able to work out what the value of a is, because then a will be the only unknown that we have. So there we go, that's y equals 0, and x squared is going to be 4 squared, so that's 16. And we've got 4 times 10, so that'll be minus 40. And then we're still left with plus 25a and minus 3. So everything, the only unknown now we've got is a, so all we have to do is collect like terms here. So if we do that, we should figure out that 16a plus 25a is 41a, and 41a minus 40a is 1a, so a. And then just rearrange that to make a the subject, and there we go. We've worked out what a is. We're done. So then all we have to do is substitute in the value of a that we found into the equation I've highlighted there, the expanded form of the completed square. So if we do that, you get 25 times 3 at the end there, 75. 75 minus 3 is 72, and that's it. So that's what it wanted. So it wanted our quadratic, and it wanted the coefficients of x squared and x, which we found there. So a is therefore 3, b is minus 30, and c must be 72. Now, there are different ways that we can go about this. So we'll look at another method, and I think this is quite valuable because it looks at using the equation of the line of symmetry, or using line symmetry of the quadratic, which I think is quite a good approach as well, and it's definitely good to be aware that you can sometimes use this to solve a problem. So in order to visualize that, I'm going to sketch it out. So the minimum value is at 5 minus 3, so let's try and draw in a nice little beautiful looking little quadratic there. So I'm going to try and put in the line of symmetry, so roughly down the middle there somewhere. So the equation of that line then, because it's cutting through the x value of x equals 5, so the equation of the line of symmetry would be x equals 5. And then we can use this symmetry and in conjunction with the other coordinate pair that we've been given, which we know lies on this particular function, so that was 4, 0. So we know that is the root. We know that that is the x-intercept point there, and we know it's less than 5, so it's going to be to the left of the line of symmetry. And because it's perfectly symmetrical, you need to just jump one x value to the other side. So you know it's going to be 1 less than 5, 4, and 1, 1, 5, which will be 6. So you can use that symmetry to help you. And as you know that the roots then are x equals 4 and x equals 6, we know that the quadratic in factorised form will look something like this. Now we might have to do some do some manipulation here in order to get the correct values of A, B, and C that they want. So if we multiply that out and then complete the square, we'll be able to compare it to the minimum value that they've given us in the question itself. So just complete the square. We just need to simplify that a little bit at the end. And what we'll see is that the x value corresponds with what we want. So we know we want an x value of 5 in our minimum, but the y value would come out as -1 after completing the square there. So that's slightly wrong. So we need to scale it. So in order to get -3, we just need to times everything by 3. So times every term by 3, and we scale the whole thing. And what we'll find now is that when we multiply this out, now we expand the brackets, x minus 5 times x minus 5, and then times that by 3, we should arrive at the same solution that we did previously. So let's just do that. So if we expand it, if we do x minus 5 times x minus 5, it'll give us that. And then multiply everything by 3. So we get 3x squared minus 30x plus 75. And don't forget about the little, the cheeky little -3 there at the end. And yeah, we should end up with exactly the same solution that we did last time. So that's another, it's just good to be aware of that approach. Using a line of symmetry is sometimes quite useful, or using a symmetry inherent within a sort of quadratic is quite useful. And that's it. So there we go. A is 3, B is -30, and C is 72.